Hi, today I'm just going to give you a brief introduction to the GE and some of the functionality that we've got built into this instrument. So GE is a multifunction calibrator, so we can source and measure milliamps, millivolts, ohms, frequency, and it also integrates with our pressure system as well to do pressure calibrations. Today I'm going to show you quickly how to set up the instrument for an RTD simulation into a transmitter. So we can set the 4 to 20 milliamps on that transmitter. Okay, so the GE has a capacitive touchscreen, so very much like your smartphone, which we're all used to, and it's very intuitive. So we have graphics on the front here. So as you can see, at the moment we've got highlighted the calibrator, which is what I'm going to go into shortly. We also have the heart communication functionality, the field bus functionality. We get into our settings. We can look at the status, the software build, because we can upgrade this and do improvements to the software and upgrade it from time to time. We can scroll down, we get to our advanced settings where we get into our calibration features. So this is our front screen, and we can always get back to this by pressing the home button. So what I'm going to do now is go into calibrator mode and show you how easy it would be to do an RTD transmitter simulation and setup. So this is calibrator mode. We can set a number of channels on here. At the moment there's 2 channels been set up. We got channel 1 and channel 2, and on the screen we're displaying those 2 channels now. Okay, so on channel 1, as you can see, we've got some graphics on there indicating what we can do. We can measure or source or measure a full 4-wire RTD, which up to a 4-wire RTD, and it will test all the compensation lines on there. We have our thermocouple connection here, and over on this side we have a milliamp and a 24-volt power supply. So we're working with the transmitter, so what I want to do is power that transmitter from this device. So I'm going to provide 24 volts to do that, and as this transmitter's input is an RTD, I want to simulate an RTD on channel 1. Okay, so I can actually go into this manually and do what we call a custom task and set that up for each one individually, but we also have our electrical tasks set up in here to make that a lot easier for us. And if we scroll down, and what I'm looking for here is channel 1, I want an RTD, and channel 2, I want milliamps and 24 volts. The other good thing on the graphic, it shows me where I need to connect to on these 2 channels. So quite simply now, I will select channel 1 RTD and channel 2 24 volts and milliamps. So we just select that. We can actually select these as well and put them into our favorites menu. So when you go into your favorites, if they're tasks that you use quite commonly, then you don't have to go and scroll through all the different tasks. You've just got your favorites already set up. So at the moment it's shown at the top here we have degrees C. So this is going to be where I'll simulate the RTD resistance into the transmitter. At the bottom here we have our milliamp output from the transmitter, which I will connect shortly. So here I have a rather old RTD transmitter. It's a 3-wire. When we're actually sourcing or simulating, we don't need to connect all 3 wires independently. So what I've done is I've joined the compensation wires together there. We make a simple connection on this side. So it doesn't matter which way around I do this, it's a resistance. So that's channel 1. So if we look on here, channel 1 is degrees C. Now it's a transmitter, so as you remember before, we've got 24 volt supply on channel 2. Connect that in, and straight away 0 degrees C is 4 milliamps. So this is PT100, 0 to 100 degrees C. So now what we want to do to